And the final example, example number 5, again, it's getting a wee bit more complicated again. We've got a trig function, but we've got it to a power here. So usual way, u equals the numerator, which is 2x squared, and v equals cos squared x. This one's nice and straightforward. U dashed will be 4x. And before I go to v dashed, I'm going to think of v as cos x all squared. And it's apparent here that we can then use the chain rule. Okay, so bring the power down. I'm left with 2 cos x to the power of 1. But I also want to multiply by the derivative of cos x, which is minus sin x. And that gives me minus 2 cos x sin x. And what you'll actually notice, this should be familiar from your higher formula sheet. It's a trig identity. So that actually becomes minus sin 2x. If you ignore the minus part, 2 cos x sin x is the same as sin 2x, which is a wee bit simpler to work with. So I'm just going to write that down there where that comes from. So it's your double angle formulae. And I should stress that you need to learn your higher formula sheet off by heart now, because you don't get it at this level, but you do use a lot of it. Okay, you've seen already that we use the cos and sine derivatives a lot, but we also use the trig formulae quite a bit as well. So please make sure that you learn that if you can. Okay, right, moving on then to figuring out the derivative. Quotient rule, u dash dot v minus v dash dot u, all divided by v squared. So u dashed is 4x times v, which is cos squared x, minus v dashed, which we've made nice and simple for ourselves as minus sin 2x, and we're multiplying that by u, which is 2x squared. So I'm taking that away and I'm doing minus sin 2x being multiplied by 2x squared, all divided by v squared, which is cos squared x squared. And just to reiterate some notation here, you'll notice that I used a bracket here to show that these were being multiplied, whereas here I've clearly put a dot instead of a bracket. I could have put a bracket around that instead, but I could not leave it like this. I couldn't just say 2 cos x times minus sin x. That doesn't mean times minus sin x. That looks like you're just taking away sin x. So you have to put a clear dot in to show that it's being multiplied, or if not a dot, then put a bracket around it. So we're going to tidy this up a wee bit at the top. So we've got our 4x cos squared x. Just tilt that down. Okay. I'm taking away a minus, so that means that I'm adding, and I'm going to put the 2x squared at the front. So I've got 2x squared times sin 2x. Okay, and the final part, it's cos squared x all squared. If you want to think about that again as cos x squared, and then you're squaring that, it's a power to a power, isn't it? And when you've got a power to a power, you multiply them, giving you cos x to the 4, which we know is the same as cos to the 4x, written like that. Okay, that there means the same as that. And that's us done. That's our final answer. Can't do any more with it. I could probably take out a common factor of 2x. Again, it's not really going to make much difference, so put it in anyway to let you see. 2x, and then that would be times in 2x cos squared x plus x sine 2x over cos to the 4x. I think it's absolutely fine if you leave it either way. You'll start to get a feel as you go through it for when you should probably take out the common factor. To be honest, you probably should take it out if you can. Okay.